Now, rule number 2. If the equation can be represented in the form y into f of xy dx plus x into g of xy dy equals to 0, then the integrating factor will be 1 by mx minus ny. Here also we can identify them by the form of the equation, by the form of m and n. Now look at this one. This is your m, y into f of xy dx and x into g of xy dy. Now 1 by mx minus ny will be the integrating factor. Example, 1 plus xy. Look at this one. Is 1 plus xy into y dx. What is the main thing is that, look at this two. Dx will be multiplied with y, dy will be multiplied with x, and the function, remaining function will be function of xy. So this one plus xy is a function of xy into y dx plus 1 minus xy is a function of xy into x dy equals to 0. These type of problems can be identified by just observing the equation given in the problem. If this type of problem comes, then the integrating factor will be 1 by mx minus ny. Next two rules are almost similar type of rules. Here you can see the form is del m by del y minus del n by del x whole divided by n equals to f of x, where f of x is a function of x only. Then integrating factor equals to e to the power integration fx dx. So exactly from above two rules we can see that the rules can be identified by the function given in the problem, but here we can't find them by the problem functions, but it is entirely dependent on this type of rule, this one as well as the next one, that is it was divided by n. Now del m by del y minus del n by del x whole divided by n becomes function of y only. Then integrating factor will be e to the power minus g of y dy. Examples are given, but this must be calculated first whether it will be a function of x or not. I am giving the example because you can understand from the example, after calculating del m by del y minus del n by del x whole divided by n equals to f of x, or del m by del y minus del n by del x whole divided by m equals to g of y. Okay. So these two are entirely dependent on the calculation of these two functions.